Okay, I'm going to do a walkthrough. Let me see, where is this code lab 1.3? The first one is username enumeration via different responses. And so the first thing I'm going to have you do is try and log into this account, bring up developer tools, and then say I don't have an account here. But one of the things you can do is when you inspect this, you can see the login form has a post to the /login. It takes a username field, a password field, and a button that you submit to. And then when you log in, you can see the result here. And if you look, it says invalid username. And so that's definitely not supposed to happen. It should tell you improper credentials. And so you can see that there's a field here in the HTML. It says, hey, invalid username. This is a warning. In the network, you can see when I did the login, it was a post request and it resulted in a 200 OK that gets me to this invalid username. And you can see the form data, the username here, the password here. So this is the thing you're going to try and attack. And what you want to do is first you're going to say, hey, I have a bunch of things, a bunch of usernames I want to try. And I want to see what the result is of every single login to see if it leaks the username by giving me a different response when the username is valid versus when it's invalid. And then, so for that, this is the Python program. Again, I have to take in the parameter of the site as a login. Well, actually, in here I have the host name being used. So that's basically what this is going to be. So that's what I'm going to do here. And again, I have it set up here so that I'm using the actual host name in this particular script. Other scripts will actually parse this out for me. So that's my site. I create a session. I saw the login URL was that /login path. And then what I'm going to do is I'm going to brute force all of the usernames that are there. And I've in Replit, you can basically create files. And so I've already created that file here. And in Replit, it gives you a shell. So this shell here, if you see, I basically did a wget, or I either copy and pasted. You get Vim. So I basically have all the usernames here. So it's in the file system along with my my main.py, which I just showed you in the other browser. But you have a full-on console over here. And I showed you this, I think, with the GitLab. So here I am in main.py. I open up this file, and then for every user in this file, I basically get the username. I get rid of I strip off the carriage return on the other side, and then I create the login data that I'm going to submit as the form. I post it onto that little login form, and then I'm going to write out all of the content for every single target into the file system. So every user is going to get a new file in my file system. I'm going to write out the content, and I'm going to close it. So let me run this, and it'll install all the packages. And then you can see all of the files get populated here in the file system. So I didn't parallelize this. You don't have to parallelize this particular operation. The only one that I want parallelized is the homework. I don't want you to have to do this over and over again. But I'm just going to wait for this 100. And then what we're going to do is we're going to edit the HTML files and then see how they differ. Still going, still going. And you can see when you do an ls, it's sitting there populating all of this stuff. And you do an ls minus l, and you can see a whole bunch of stuff getting populated. ls minus l, just the HTML files. And so you can see all of these things are the same. You could run a script that diffs for I in star.html, do diff, let's say vagrant is the one. And I can do, oh, so I do have something that says incorrect password instead of incorrect username. So that just did a sequential diff between vagrant.html and all of the other HTML files in this directory. And so you could, I don't know which file it was, because what I needed to have done is say echo $I and then do the diff. And then when I can scroll up, I can see Atom. It looks like Atom.html was the one. The other way to do this is if I do an ls-l of star.html. Oh, they don't have less. I'll do it to more. And you can see all of these are 3002. What I can do is I can do a sort on this. Oh, I can find the one that's different. So, whoops. Oh gosh. I'm going to do a sort on the 1, 2, 3, 4, 5th key. And then you can see at the very end is where Atom shows up. And this is at 3004 instead of 3002. So then let me look at what Atom.html has. Oh, that's not very readable. Can I change the color scheme on Replit? No, I don't want to record a macro. Actually, what I want to do is, that's what I want to do. Sorry about that. And you can see here, the is warning has incorrect password instead of incorrect username. So that leads us to the next version of this program that will actually solve the level. So again, here's another program, and I'm not going to run this actually. Again, same program initially. What I'm going to do, instead of just saving the file, I'm going to parse out the HTML, and then I'm going to check. So the two differences is that the class is warning had incorrect username on the username one and incorrect password on the other one. So if it cannot find the username in the is warning p tag, the text of the is warning p tag, then I have found the valid username. So then that's the target. And then what I can do is I can do the similar brute force operation on the passwords. And so I know that the login data is the target, the password is read from a file. And then I can just basically look to see whether or not this is warning. So again, this is a similar check as the one up here. But this is a check to see, because you'll get the incorrect password until you log in appropriately. Now, you could do a different conditional on this. You could actually check for a redirect, I think. It actually redirects you to the main page, I believe. And then you can go and solve the level by going and visiting the My Account of the target that you hijacked. OK. So are there any questions about that? The Replit, oh, I'm going to have to fix the access problem on there. OK, the one I really want to get to is the one for your homework. So let me get to the homework. This is 2FA bypass using a brute force attack. And so in this case, oh, let me start it up because it takes a while to start up. So this is basically well, one of the things I wanted to make a note of is that your initial program is specified here. And if you've already gone through this already, the key part is that we need you to add this to your program, because what we want is everybody to implement the same way of supplying the URL that you're going to attack. And this is for the sake of the TA. So this particular thing is new if you've already done it, but make sure you follow these instructions faithfully so that we can get everybody on the same page. Okay. Okay, so this is the 2FA bypass using, oh wait, I don't want to do this. I'm doing a different one, sorry. I'm doing broken logic. And by doing broken logic, this will, oh, hopefully I haven't gone over my limit of PortSwiggerLevels to instantiate. Otherwise, I got a problem. Oh, this is broken logic. Sorry. So again, this is not a level that I have assigned to you, but it's set up in a similar way, and the solution is quite similar. In fact, actually, this level is harder than the one I assigned because this has got multiple things going. A little bit harder. It's not substantially harder. Dang, I used the, yeah. So this is an expert level that I assigned, and this is the practitioner. So I think solving the practitioner one. Wait a minute, that's okay. Not going to judge. Okay, so the first thing I want to do is walk you through how this login works. So I'm going to go to my account. I'm going to inspect the page. And then I'm going to view the login form. And you can see for this particular one, this doesn't have a CSRF token like your homework one does. It just has the regular form, username and password. And so we are given, in this level, we are given the credentials, one of the user's credentials. And so this is to allow us to understand the workflow of the authentication. And then what we're going to be able to do, because the workflow of the authentication has some broken logic in it, this will allow us to authenticate as Carlos without knowing his password. So that's this particular level. And I'm going to show you the logic flaw first. And so we go here and you look, this is a login form. And so I'm going to log in as the credentials that I've been given. And when I log in, you can see that this thing redirects to a form that asks me to enter a 4-digit security code. Now, there is an email client that you have access to that will basically give you the security code. And so I'll open that in a new tab. And so what you would do is you would say, oh, this is, and this is the account's email. You say, oh, I was given this 1332. So then I should go back here, type 1332, and then this should get me back to my login page. Okay, so that's the idea of this thing. Now, what we're going to do is we're going to go and look at the network connections that led us to this page. And the first thing you see is the original post. And so the post goes into the /login and it gets a found, but it gives you a redirection. It says, you know what, go to a different site. And moreover, as part of this redirection, it says this, it sets a cookie that says, verify the account wiener on this path. So it sets a cookie on your browser. And this is a cookie that you will then subsequently send to login to, because the location that you visit on the redirect is /login2. So that's where this request comes from. And of course, this set cookie says the session cookie should be secure, HTTP only. It could be done on any site, but that's basically what it is. So this is the login flow. And so this is the vulnerability. You get redirected to login2. We don't know if it's vulnerable yet, but we'll prove that it's vulnerable later. But like, this is basically setting a cookie and making the cookie give you semantic information about your identity. So we can tamper with this. The redirect happens so fast that you can't do the tampering in the browser very, very quickly. But this is happening very quickly to get you your login to. And then the login to happens, and you see this request URL to login to, and then it gives you the content back that you see here. Now, the security code that we were given was 1332. So now what I want you to want to show you is the difference between giving the correct code and giving the incorrect code. So here I'm going to give the incorrect code, which is 1111. And I'm going to log in, and you can see it goes to login 2, and it gives you an incorrect security code. So here is the login 2 request, and it gives you a post, and the result is a 200. So the page that it gets back is as part of this page, it gives you a 200. You can see the response, and the response has in the P class an incorrect security code. So this is your way of determining that the 2FA code did not work. You can actually look for you can look for both the status code, as it turns out, as well as this text in the payload. So now what I'm going to do is show you what happens when you successfully enter a 2FA code. And so that was 1332. And so if I log in with this, you will see that you get back into my account. And so if you go to this request, you will see in the headers, you'll see a redirection, and the redirection goes to /myaccount. So this is where you can just check the HTTP status code to determine whether your 2FA worked or didn't work. So that's the gist. Now, the question that comes up is that when I get my 2FA code, so let me log out again and log back in. The question is when I submit a request to get my security code. Oh, sorry, I needed this up before I did that access. Sorry. Okay, so Peter. So when I do this request and I go over to the network, the question is in the /login2, if I look at the request headers, and this is going to get me this page, what happens when I hit /login2 is that a new 2FA code is created and sent to the user specified with this request cookie. So when I hit the login2, it basically will parse this login cookie and say, oh, I need to send a 2FA code to this person, a new 2FA code. And so if you keep hitting /login2 with this particular cookie, the account that's going to get the 2FA code is this account. And then when you submit that code properly, you are automatically authenticated as that user. Now, the question is if I can forge this to be Carlos, and I submit this /login2 request as Carlos, can I brute force Carlos's 2FA code and then get a login as Carlos through this 2FA process without having logged in first? So I think this workflow assumes that the only way you can get into /login2 is to successfully get /login and then to get redirected to /login2. So that's the vulnerability in this particular level. And it's similar to the one that you're doing in terms of the brute forcing of it. Okay, so here's the very first program, and this program logs in as the user account. And then what it does is it basically looks at the status code that you get back from the login. It looks at the headers, and it prints out the cookies from that initial login to dump the cookie state to show you that the verify equal wiener is the cookie. And then what it does is it simulates the next part of the login flow. It visits the /login2 path with that cookie set, and then it pulls up it visits that site to get the 2FA code sent, and then it pulls out the email URL because we have to go access our email to pull off the 2FA code that just got sent. And then this piece of code will just parse that HTML that I showed you before that had the 2FA code. This pulls out the code from that web page, and then it turns around and it shows you it posts a bogus code, assuming that 0000 wasn't the code. It just posts that to show you that the warning message will be there when you submit the wrong code. And then it will submit the actual code to /login2. And then when it gets the results back, it will say, this is the status code, and then this is the location of the redirect. And then, of course, you can actually get the redirect page. And this should show you that you have properly done the workflow for the 2FA. So let me run that. And I'll make sure that you can look at this code after class. Oh, shoot, I forgot to set the site name on it. All right, now I can do it. Okay, so this is the login using the legitimate account, and then is a 302 to get you to the /login2 that sets the cookie, the verified cookie. So the session cookies now have this here. I'm going to visit login2 using those cookies to get the 2FA code emailed, and then I'm going to get the email URL and parse out the code. It parses out the code as being 0692. It tries to log in using the 0000 code, and it sees that this results in a status code of 200, and it pulls that incorrect security code error message out of the page. And then it submits the actual MFA code, and then the correct code results in a 302, followed by a redirection to my account. And then I can go and I can grab the account for the legitimate user. And then you can see, you can see that I have appropriately logged in as the account that I'm given. So that is the intended behavior. The next thing I'm going to run, show you the next program, is to show you that you can forge the cookie. This is not in your homework. This is something that for this particular level, I'm going to fake that I am the Carlos account. And I'm going to see if I can get a 2FA code sent to Carlos. And that's basically what this program is going to do. Again, this is similar. Oh, actually, sorry. What I'm going to do is I'm going to avoid logging in at all. Like, they gave me the account, but can I do just a 2FA authentication without username and password? So the assumption is that only a successful /login submission will get you to the /login2. And so this is a program that shows you I can just go straight to the /login2 by minting a cookie that says that I am the legitimate account. And that's what this thing does. And so this particular code here just creates a cookie. So again, here's the login URL. I don't even actually need this. I don't think this gets used. I'm gonna mint a cookie that says the verify cookie is exactly what it was before. So I'm going to recreate the cookie that I would have gotten from the successful login. I am going to set this cookie into the session object. I am going to get the 2FA code sent to the regular email account, and I'm going to do everything again as the previous program. So again, let me paste the account, and then I'm going to run this. So I'm going to just visit login2 directly, and then see if the 2FA got sent to me in email. And of course, now it's 0971, so I'm going to submit that and grab the account page. And as it turns out, yes. So all you need to do is forge a cookie and then get the code, and you don't need the username and password on an account. Okay, so that's the demonstration that the process is broken. The next one is to create the Carlos account, or to do the exact same thing as what we just saw using Carlos's account. How much time do I have? Oh, I'm going to be late for my next class. Oh, well. It's okay. They're very forgiving. So let me do this again. So here I pretend to be Carlos. I get this cookie set. I get the 2FA code. And then what I'm going to do is I'm going to brute force that thing because I don't have access to Carlos's email. And so what I do is I go from 0 to 2000, and the MFA code is 4 digits, so the leading zeros must be given. And so that's what the Z-fill, the zero fill up to 4 digits means in this case. And then what I'm going to do is I'm going to go for every single code in 0 to 2000. I'm going to post this. And then I'm going to check for a 302. And if the 302 is found, I'm going to finish the level by accessing the My Account page. So that's basically what this is going to do. I mean, I'll run it, but I'm not going to wait for this thing because I'm kind of in a rush. But then you'll see something like this. So it might help you to do a single-threaded version to know that your logic is correct in solving this first before you go and you do a multi-processing version. And so that's what this is. This is the single process version. This will take you about, when I was doing these single process tests, about 15 to 20 minutes to solve. But I don't have time for 15 or 20 minutes worth of stuff. So I'm gonna get rid of this. And then I'm gonna go to the last thing. The idea is you don't want the TA to have to wait 20 minutes because your program will get deducted and she'll be unhappy. And so what I want to do is well, I don't know if she'll be unhappy. She actually is a very positive person, so maybe I'm projecting that. The Lab 2FA Broken Logic 4 it's a scaffold, and this is to show you how you might do a multiprocessing version. You can also do an async IO version, especially on Replit. You don't have a very well endowed machine on Replit. So you might find that the async version is better to do on Replit. But this is so if we look, this is the code, the sequential version that we have now embedded in another function called trycode. And so in this case, trycode takes a start range, an end range, and the session object to perform the request with. And then for all the digits in between the start and the end, I will do this operation, the post. And then if I get a 302, I'll say the code is found. And then in this case, don't finish the level. You can so in your homework, we want you to spit out the code. And then she can test that separately if she wants, because otherwise it locks her out of the PortSwigger site. If you finish the level for her. So, and then here you would fill in your host name again. Oh, this code actually doesn't run at all. But here's where I am talking about when you are in the reason why this little syntax exists. This prevents a multi-processing version of this program from re-executing this code. This code only gets executed the very first time you run the Python interpreter on the script. And what happens is it sets up the initial session. So you only have one session state. It adds the Carlos cookie to that session. And then what it does is it visits the login to page to get that 2FA code. And then what you want to do is here is where you want to do the multi-processing code, because you never want to visit the login to URL more than once, because you don't want a moving target, because every time you hit the login to URL, you get a brand new 2FA code. And so you want to make sure none of your other processes will invoke the login to site. And so if you were to have put this, and a lot of people have done this already, if you were to put this here, the problem with this is that any multiprocessor version of this will, if you say execute trycode in multiple processes, what it's going to do is it's going to, on initialization, it's going to re-execute anything that's in the main context of the Python script. And that's just an artifact of how multiprocessing works in Python. And so this is why you need to protect the login to process within this main if underscore name is equal to main. So that's the thing I really wanted to get to. And then I am not going to give you the multiprocess version because this is your homework. Okay, so with that, I am now done. Thanks for sticking around. I will get this video and those links up as soon as I'm done with my other commitment. All right, thanks everyone.